Okay, so this is a random video. It's about trigonometry, specifically inverse trigonometric functions. I got back to them and it was a task understanding the concept again. So here is my view on it, the way I understood it. I'll give a short brief of trigonometric functions first and then inverse trigonometric functions. So very briefly, uh, let's let's do let's understand trigonometric functions first. So say this is my x-axis. Sorry, this is my y-axis and this is my x-axis. Okay. So what trigonometric functions do is that basically they are associated with a triangle, right-angled triangle, and this is like the most basic idea. So say if this angle is theta, this is 90 minus theta, and yeah, trigonometric. Okay, I need to make videos more frequently. I'm losing my touch. Anyway, so see what trigonometric functions do is that they give us the ratios of these three sides. And this means equal, but this does not mean they're equal. Okay, so it gives us the ratios. Like if this is hypotenuse and this is the altitude and this is the base or perpendicular as we call it. Now this will be the base if you're talking about this angle. Let me name this triangle ABC and this is base B, right? So if you're taking angle C, then BC is the base, and if you're taking angle A, then AB is the base. I hope you already know this. Okay, so yeah, let's dive straight into the trigonometry. So what you need to understand is like trigonometric functions. They are sine, cosine, written as cos, sine, cosine. Okay, and let me first explain sine, cosecant, and then tangent. Okay, so sine function. Let's mark the points. Say this is pi over 2, this is pi, this is 3 pi by 2, this is 4 pi by 2, which is actually 2 pi, then this is 5 pi by 2, then next will be 6 pi by 2, which is actually 3 pi, right? So if you have hard time understanding this, learn it this way, right? And this side, again, same thing, negative pi over 2, negative pi, negative 3 pi over 2, right? Now sine function is basically this function. Yeah, I need to mark. Okay, this is -1 and this is 1. This is y-axis, this is x-axis. X-axis has angles in radians, okay, and y-axis has the ratio of whichever side, sorry, ratio of whichever side the trigonometric function refers to. Okay, so we know sine 0 is 0, so I start the graph of sine with this. Sine 0 is 0, so I draw it like this. Sine pi, oh my bad, yeah, it can't cross 1, right? Okay, bear with me. Yeah, right, so it goes like this, and in this direction again, -1, then +1, like this. Okay, so this is the graph of sine function, right? Remember, angles on the x-axis and ratio on the y-axis. Now ratio cannot be more than 1 or -1. Ratio of what? Sine gives us the ratio of perpendicular and hypotenuse. Sine is perpendicular upon hypotenuse. So this black one is the sine of theta, right? Okay, I don't need to over explain this. You already know this. Let us draw the graph of now cosecant x. Okay, cosecant theta or x, anything, doesn't matter. Okay, for the sake of clarity, this x is theta, right? Now, see, cosecant is the inverse of sine, right? So when sine theta is 0, what will be 1 upon, sorry, what will be 1 upon sine theta? When sine theta is 0, 1 upon sine theta will approach infinity. It will not give us a definite value. It will just not be defined. It will be approaching infinity. The value will keep getting larger and larger. Okay. Like when sine theta is approach. Okay, I don't need to over explain limits, right? Let's stick to trigonometry. So when sine theta at pi by 2, sine theta is 1. So 1 by sine theta, which basically is cosecant theta, that will also be 1. And when it is 0, then cosecant theta will be infinity. So the graph of cosecant theta is like this. Let me draw an asymptote pi, right? So cosecant theta like this. This point is included, right? So this is cosecant theta. Then next portion will be like this, like this. It never touches this line, which is x equal to pi, x equal to 2 pi, x equal to negative pi, x of theta. I'm sorry, but I'll be mixing them. Bear with me on that, right? So it never touches this line. This is an asymptote. All of these x equal to 0, x equals pi, x equals 2 pi. So this is cosecant theta right here. Okay, just on the outside of the range of sine. Okay, so cosecant theta can take all real values except the values between -1 and 1. Between -1 and 1, they can take 1 and -1, right? So its range will be all real values minus the interval -1 to 1. Okay, now let's do tan theta now. And I'm sorry for the, yeah, let's take tan theta. Okay, that color is too light. Oh, it will do. Now tan theta is sine theta upon cos theta, right? And we know that, okay, my bad. Instead of tan theta, we'll take cotangent of theta, right? Cot theta. Cot theta is, as you know the identity, cosecant square theta is 1 plus cot square theta, right? So they are related like that. Okay. So cot theta is what? Cos theta over sine theta? Cos theta over sine theta. So again, the same thing. When sine theta is 0, cot theta is not defined. Also, let us draw this unit circle. We know ASTC, right? All trigonometric ratios are positive. Sine and cosecant are positive. Tangent and cotangent are positive. And cos and secant are positive. Okay. Now, look. So when is a cot positive and when is it negative? Cot will be positive here and here. This is 0 to pi by 2 and then pi to 3 pi by 2. This is where cot is positive from 0 to pi and from pi to 3 pi by 2. So what is this interval? 0 to pi. And see, 0 to pi by 2 cot is positive and then pi by 2 to pi cot is negative. So that means cot will be like this and then this. Okay, this is more curved, like, okay, something like this. This is the graph of cot. Okay, very basic. See, from 0 to pi by 2 cot is positive. So instead of drawing it like this, we have to draw it like this, the way I drew it. Okay, and this looks pretty messed up. I hope you understand it. Okay, and yeah, let's now do the other three ratios. Okay, very quickly. So this was our axis. Again, angle ratio, right? Y-axis, x-axis are theta. Let me mark the points again quick. This was pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. Okay, so now cos, again, give me a moment. Yeah, first let's draw cos theta quickly. We know that cos 0 is 1, right? And then see, cos is positive here and here. So in 0 to pi by 2 cos will be positive, and then after pi by 2 cos will be negative. 0 to pi by 2 cos is positive, and then pi by 2 to pi cos is negative, then again negative, then positive. Okay, like this. And similarly in this direction, right? So this point is negative, positive 1, and this is negative 1, right? Yeah, so this is cos theta, positive in first and fourth quadrant. This basically represent, this is 0 origin, so this basically represents first quadrant and this is the fourth quadrant. Okay, now, yeah, so this is cos theta. Okay, now secant theta is the opposite of cos theta, right? So secant theta, when cos theta is 1, its reciprocal is also 1. Okay, so in this case the asymptotes will be when cos is 0, because secant theta is 1 by cos theta. When cos theta is 0, secant theta will be undefined. So our asymptotes will be here. And secant theta will be like this. I'm not sure if this shape is accurate. It's just very vague. This point touches. This is a part of the range. Okay. Similarly, this side, asymptotes, yeah. Okay, so this is secant theta. Now you can go back and see the comparison between cos secant and then sine cosine. Okay. Now, in the similar fashion, okay, why I'm taking them together, grouping this cos secant and tangent together is because They show similar pattern from negative pi by 2 to pi by 2. This will help us understand the inverse trigonometric functions better. Okay, so very quickly let's go through the tangent as well. Now tan theta is what? Sine theta over cos theta. Again the same thing, cos theta in the denominator. That means when cos theta is 0, tan theta will not be defined. Now tan is positive here and here, right? So in 0 to pi by 2, tan is positive. That is enough to give us some context. 0 to pi by 2, tan is positive. So my graph will come from here. Oh my god. Okay, my graph will come from here, cross 0 here. Okay. And 0 to negative pi by 2, 0 to, sorry, yeah, here. Why, sorry, I'm sorry. Yeah, in this fourth quadrant, which is 0 to negative pi by 2, 3 pi by 2 is same as negative pi by 2. In this, our tangent is negative. Okay, these negative values of y, right? Yeah, I hope this is clear. And if you still have doubts, just ask me in the comments, and I'll make another video for inverse trigonometric functions because this will be too long otherwise.